Okay, so this is Mrs. Lehman from Math with Mrs. Lehman, and the fact we haven't done a YouTube video in so long is making some people giggle right now. But anyway, today we're going to start Module 5, which is area, surface area, and volume. So the first thing we're going to do is our bell ringer, but we're going to learn how to find the area of parallelograms today. So this bell ringer is a throwback to Module 1. We have two equal ratios. We call that a proportion. So essentially we have to scale this up. So we have to figure out, how do I get from 5 to 40? What do we need to multiply 5 by to get 40? Abby?
5 times 8.
Very good. Times 8. So you do the same thing up here. So 4 times 8 is what, everybody?
32.
Yep, so x equals 32 in this case. All right, who had x equals 32? Very good. The smart board has decided to go on strike. All right, this next problem, we're looking for the connection between 9 and 72. What would that be? We multiply it by what, Paula?
8.
Very good. By 8 again. Really creative, Mrs. Lehman. Picked the same number. All right, do the same thing to the bottom. 11 times 8, everybody is?
88.
X equals 88. All right, good job. All right, so now we're going to go back to the days of kindergarten where we are identifying shapes. Actually, we're going to be a little more advanced than that, but the opening exercise has these shapes we need to identify, so we're not going to waste a ton of time elaborating on this. Okay, is everybody ready? All right, thanks. Okay, the first thing we notice has 3 sides here. What do we call that?
A triangle.
Triangle, very good. And what type of triangle?
A trapezoid.
Tucker, what type of triangle is that? A right triangle, good. So how do we know it's a right triangle and not a wrong triangle? Ha, ha, ha. What makes it a right triangle? Lonnie?
Because there's a square thingy on the right.
Yeah, what type of angle, or how many degrees I should say, is in a right angle? Rihanna?
90 degrees.
Very good. So that symbol there means that is a 90-degree angle. All right, so this second one, does anyone know what we call this? Quadrilateral. Evan?
A trapezoid.
Nope, actually that is not a trapezoid. Liliana?
A rhombus.
Nope, it's not a rhombus. Lorelei? Very good. It's a parallelogram. So these symbols mean that those sides are parallel. So that's a parallelogram. And a parallelogram has 2 sets of parallel sides. Right? So they will, if they were to continue on and on, they would never intersect. All right, this next one is also a triangle. Does anyone know what type of triangle that would be? Michael? Nope, it's not isosceles, actually. Somebody else? Liliana? Equilateral, very good. So you see the word, oops, sorry, I'm pushing buttons here. You see that all sides are equal, so equilateral, lateral meaning side, equal meaning they're equal. It's an equilateral triangle. All right, so this next one, pretty obvious. One of the first shapes you learn. What is that, Rihanna? A rectangle, very good. Now, what's the difference between a rectangle and just any old parallelogram? A rectangle is a parallelogram. But what is specific about a rectangle? Xavier?
It has 2 short up lines and then 2 short sideways lines.
So it has 2 sets of equal sides. We'll go with that. Okay, Lorelei? It has 4 right angles. Very good. All right, and then this one is a what? We'll go back to Evan on this. What is this one called?
Trapezoid.
A trapezoid. Now, a trapezoid only has 1 set of parallel lines. All right. So if we were to continue those sides further up, they would intersect eventually. So All right, so we're going to focus on how to find the area of parallelogram. So based on this set of shapes, things that look like this and things that look like this. All right, so those are the ones we're going to focus on today. So in each of these exercises, they're going to give us a parallelogram, and we have to write the formula. So the area formula for a parallelogram is area equals base times height. And we capitalize the letter A for area, lowercase b, lowercase h. Now, I'll have to draw this, so pardon my lack of artistic skills. But so when you're finding the height of something, you need to make sure that it is perpendicular to the base. What does perpendicular mean? Lonnie? No. Kaden? No. Yes. Lorelai? Very good. Lorelai just said they form a right angle, so they form a 90-degree angle. So with a rectangle, the side does that. Now with a parallelogram, the side does not. So we have to look for the height. We're looking for a set of perpendicular lines. In this case, it's not part of the side, right? It's just this dotted line here, meaning it's not, an actual side in this. So what I'd like to say is give this example. Raise your hand if you have ever been to a doctor or the nurse's office and they've had to measure your height. Right? And you guys know kind of standard procedure for that is to make sure you're forming a nice perpendicular line with the floor, right? You want to form a nice 90-degree angle, stand up straight, whatnot. So I'll draw what I'm going to demonstrate. So here's, let's say, the wall. Here's the floor, right? So if you went to the doctor's office and they said, stand up straight, we're going to take your height, the doctor would be pretty irritated with you if you did that, right? All right, so I'm going to demonstrate in person. So if you went to the doctor and stood like this, they're going to tell you to stand up straight, right? So you've got to make sure you're perpendicular. So I'm gonna erase my picture now. So anyway, there was a story from a few years ago. I gave that same example, and a kid, like I said, if you went to the doctor and did that, they would get quite irritated with you, right? So a kid wanted to test this out. He had a doctor's appointment. He had a very strict father who took him to this appointment, and the kid decided it would be a great time to test this out. And so he comes back in a few days later and says, Mrs. Lehman, I went to the doctor and I stood like you said not to, and I got yelled at by my dad. I got grounded for acting like that at the doctor's office. So anyway, here's my qualifier. Do not try that at the doctor's office or at home. Make sure you're standing perpendicular to the floor.
Wait, why not try it at home?
Well, that's not your height. Right? If you're measuring your height, you need to be perpendicular. Anyway, moving on. You get the point. All right? Now, in this first example, they made it really easy. They gave you the base of 6 and the height of 4. No questions there. We're just going to plug in. Base is 6 times the height of 4. So you start with your formula. You plug in your base and height. You go ahead and do that multiplication. You're going to get 24. And then the unit part is what comes next. So when we're measuring length, it's just centimeters, but if we're finding area, you're actually going to have square centimeters or centimeters squared. So that's how you would write that. And that means if you had 1 centimeter by 1 centimeter squares, it would take 24 of them to cover that parallelogram. Okay, if you look down at our floor here at school, these tiles are 1 foot by 1 foot. We could count every tile in here. It'd be kind of tricky with some of these partial side tiles, but we could figure out how many tiles it takes to cover the area of this floor. So you use area when you're painting walls, when you're covering a surface, maybe with wrapping paper, you're covering a floor with carpeting or some sort of flooring. Yes?
So did we multiply to get 24?
Yes, you multiply. Remember, when you have two variables right next to each other, that means multiplication. Okay, so a little bit of a review from last module. Yes?
I don't understand
Okay, so here's your formula. Whenever you want to find the area of any parallelogram, you got to multiply the base and the height. So you're just multiplying the two numbers. Really, the tricky part is picking up the two numbers, okay? In this case, it's really easy. Here's the base, here's the height. So you're taking 4 times 6. That's how you get 24. Where did the what? The centimeters squared? The exponent of 2? Yeah. All right, so what that means, like if we were to measure a centimeter, let's say that's a centimeter, okay? That's a measurement of length, but we're not measuring the length. We're measuring essentially what is the area of this whole thing. Well, how many square centimeters does it take to cover that entire thing? So a square centimeter means a centimeter by a centimeter. So it means how many square units does it take to cover it. All right, so you could see it written like this, or you could see 24 square centimeters. And I like to teach you both ways because every question could have like a multiple choice section that's a little bit different. Some might say centimeters squared and some might say square centimeters. All right. So let's look at the next one. All right. So they're kind of making it a little tiny bit more challenging. They have two numbers here. So we know the area of a parallelogram is base times height. What is our base? What's our base? What is our base? Paula? 25. Very good. So we're going to plug in 25. All right. And what is our height? So we have to decide between the 8 and the 10. What is the height? Cruz. The 8. Who agrees with Cruz? We're going to pick the 8 instead of the 10. Nice job. All right. So we're going to say 25 times 8. So the area 25 times 8 is what? How do you choose the 8? So do you see right here at the bottom, there's this little box? That shows that those are perpendicular. For it to be the height, you're looking for that one that forms a 90-degree angle with the base. Okay? So in this case, that 10-meter side is tilted, right? That's not perpendicular. We were looking for the 90-degree angle. So anyway, what's 25 times 8, Jenna?
200.
200, very good. So 200, and what unit would I pick for this? Xavier?
Meters. Meters.
Meters what?
Squared.
Squared. You have to have square units when we're finding area. So meters squared, or you might see it 200 square meters like that. Okay? So I like to show you both ways again because sometimes you'll see it more written out like square meters. Yes?
What is the other part? Like the other number, 10? What is
The 10 is a side length. So you may need that if you're, you will need that if you're asked to find perimeter. Perimeter is the distance around the outside, right? So you would just add all the side lengths together for any polygon to find what the perimeter is. But because we're finding area, we're not interested in that. Okay? Any questions? You've had good questions so far. All right, let's look at the next one. We have 12 here, 7, and 11 and a half. So what two numbers do I need to multiply to find the area? Liliana? 12 and 7. Very good. So 11 and a half is the side length, but we're not looking for the side length. So area equals base times height. Area equals 7 times 12. Everybody, what is 7 times 12? 84. And then what unit would I have for this, Jenna?
Square.
Very good. Feet squared or square feet? You might see it like this. Now, if you guys have ever, I don't know if you guys would really be looking at real estate advertisements and stuff, but often when you're looking at listings for real estate, meaning how people have their houses for sale or maybe an apartment for rent and whatnot, you'll see how many square feet the house is. That means essentially how much floor does this place have. The more floor, the bigger the area. All right? Any questions? All right, so the next thing we're going to do is keep exploring what that height is. So we're not going to measure anything. We're just going to draw in the height for this set of parallelograms. So you'll see the height often drawn with a dotted line, and the reason we use a dotted line and not a solid line is because it's not a side. It's not an actual side of the parallelogram. It's just, you know, showing the distance between the one base and the other base, right? So that would be the height there. You could draw it up from this corner there. Now you can also indicate this on the outside of parallelogram. So right here would be another one, and you'll see maybe a little connector there. Pardon my lack of straight line drawing. So you could see it in any of those places. So please make sure your paper matches that. All right, so the next one, same thing, nothing really crazy here. So you just go straight down from a corner, or straight up from a corner. Vertex maybe would be a better word. So any of those four places you'd really see the height. All right, so the next one does kind of pose a bit of a challenge because a lot of kids try to draw the height in right here. So don't write down what I'm about to do because this is wrong. A lot of kids go like this and they go, oh, that doesn't seem quite right. It's because it's not, all right? That'd be like taking your height and measuring only to your knees, you know? So this parallelogram is not wide enough for you to really show the base going from the bottom, or I'm sorry, the height going from all the way from the bottom to the top, but what we need to do in that case is definitely draw it on the outside. So you could see it in one of those two places. So again, this would be the height here, this would be the height here. And they've already labeled the base. All right, you're gonna wanna make sure that connects right to this line because you came way up. All right. Okay, we're gonna skip number 3. And we're going to go to the problem set, which your homework is the problem set. You're going to have a good amount of time to get started. But there's a few that I would like, well, one I would like to look at with you. So right here at the lesson summary, it says the formula to calculate the area of a parallelogram is area equals base times height, where B represents the base, H represents the height. And it says the height of a parallelogram is the line segment perpendicular to the base. The height is usually drawn from a vertex that is opposite the base. So those are all things that we already talked about. Let's look at 1 and 2. You have to draw and label the height of each of those. We're not going to do that right now. On number 3 and 4, there's a few trap answers, all right? Because math wizards love to give you info you don't need, all right? So you're going to have kids that are using the side length instead of the height. Don't be that kid, all right? Make sure you pick the one that's perpendicular to the base. Now, let's go to the next page where we have some more challenging ones. I'm going to go through number 5 with you right now. All right, so number 5 initially looks pretty overwhelming. We have lots of numbers there, and when kids see lots of numbers, they think we just got to do something with them. They're not comfortable leaving them there. They think I got to add those. I got to use all this stuff, right? The reality is we only need 2 of these 4 numbers listed. Can anyone tell me one of the 2 numbers that we need? Lorelei. Very good. The base. Which number represents the base? 2.5. Very good. This 3 and 5, 6 is essentially worthless to us. That is not useful for anything. It's there to trap you. All right. Now the height. Would that be 7 2/3 or would that be 5 1/4? Tucker. 5 1/4. Very good. So those are the 2 numbers that we need to use. So the process still applies. It's just now we're dealing with some fractions instead. So first things first, we always write our formula. So write down area equals base times height. Now we're going to plug in for this particular parallelogram. So our base is 2.5 inches. So we're going to write 2.5 in parentheses, and then our height is 5 1/4. So step 1, write the formula. Actually, step 1, identify the base and height. Step 2, write your formula based on the shape that you have, in this case a parallelogram. Step 3, plug in. Step 4, calculate it, okay? So to calculate this, we do have another step. What do we need to do in order, or before we multiply these? Xavier?
Well, because you can't really multiply the 4 and the 2 and the 1 and the 1 you can, but you need to change the 4 and the 2.
We need to do what with these? Turn these fractions into what, Lorelei? Very good. Improper fractions. So just a reminder how to do that. You take your bottom number, your denominator, times your whole number, add your numerator. So you're going to take 2 times 2, which is 4, plus 1 is 5. So that's going to be your numerator over your original denominator. So 5 halves is the same as saying 2 1/2. All right, and then the next part, we have 5 1/4. You can tell me what that would be as an improper fraction, Jenna?
21/4.
Very good, 21/4. All right, how do we multiply fractions, Michael? Before you multiply them, you have to put them as improper fractions. That's a review of last year's material, and we talked about it in Module 2. So before you quote-unquote send them to the operating room, we got to put them in proper form, right? So part of that for fractions is putting them as improper fractions. All right? That's just what you got to do before you multiply. So how do we multiply fractions? Liliana? Multiply them straight across. So 5 times 21. What's 5 times 20? 100. 5 times 1 is 5. Add the 2. You have 105. All right, so 105 over 2 times 4 is 8. So we have 105 over 8. All right, we got to get this number back ready for the real world. 108 over 8. So let's turn that back into a mixed number. Oops, not 108, 105. 105 divided by 8. So 8 goes into 10 how many times? 1 time. That gives you 8. You subtract, you get 2. Bring down your 5. 8 goes into 25 3 times, which gives you 24. Subtract, you get 1. Now, some kids were really tempted earlier today to turn this into a decimal, which you could do, but I would like you to know how to operate with fractions. So what do I do with that remainder? Very good, put over the 8. So we have 13 1/8. So 13 1/8. And what would our units here be? Inches what? Squared. Whenever you're doing area, it should be units squared. So inches squared or square inches. Now, what a lot of kids do, and I want to warn you against this, is they don't estimate. They don't check reasonableness of their answers. So one thing I want you to look at is, all right, I have the number 2 1/2 and I have the number 5 1/4. So that's above 2, right? And that's a little above 5. So we have 2 times 5. What's 2 times 5? 10, right? So you know your answer should be above 10. Does that make sense? Should be a little above 10. Now, if you look at this, you could say that's a little less than 3, that's a little less than 6, right? So it should be less than 18. 6 times 3 is 18. So you know your ballpark answer should be between 10 and 18. Well, does 13 match that description? Yeah, so it's reasonable. If you got something like 100, that should kind of tell your brain that doesn't seem like a likely answer. I goofed up somewhere, okay? So the more you can estimate, the more apt you are to be accurate, because if you do a goof up, you'll catch it, okay? So 13 1/8. Now question number 6 is pretty much exactly like that. You're going to be given extra stuff you don't need. You've got to sort through that. Down here, you've got Brittany and Sid, both asked to draw the height of a parallelogram. Their answers are below. And then you have to decide who's right. Are they both right? Yes, no. Is only one right? Why? So you're going to essentially grade that paper, set of papers, and see who's right, who's not. And then the next page, I'm not going to have you do, but you do have to do question 8 here. and calculate if these have the same area, okay? So anyway, virtual Mrs. Lehman will go over that with you tomorrow. So I will not be in school tomorrow. So make sure you have that done, and we'll talk about it. We'll quote, air quote, talk about that tomorrow. Any questions before I give you work time? All right, so again, what are the steps of finding area of a parallelogram? First, you've got to do what? Determine the height and the base. Step 2, write the formula. Step 3, plug in the formula and then multiply. All right, and then label. So, oh, actually, if I could have your attention real quick, there is one more thing I'd like to show you guys. So, you guys are used to seeing parallelograms like this one, right? So, a classic thing that you'll see is you have that parallelogram and you're like, oh yeah, I know how to do this. But then somebody tries to be tricky and they go like this. Whoa, oh, now you'll never figure it out, right? And it freaks everybody out. Same concepts apply. You're looking for the you're looking for the perpendicular line. So this could now be considered your height, right? And this would be your base. All right, it's just on its side. No big whoop. All right, instead of saying no big whoop. No, they said. Okay, anyway, no big whoop. Thanks for watching Math with Mrs. Lehman. If you like watching very corny math videos and long drawn out module lessons, don't forget to subscribe because this is your place. Anyway, thanks for watching. Have a great day, and I'll see you tomorrow. Bye.
Bye.